Hello there and welcome to this tutorial. Today we're diving into dynamic sprite manipulation in Unity, and we will create a program to let the user control the position, the size and the rotation of a sprite using their keyboard input. And by the end of this tutorial you will have an interactive project where a simple sprite responds to user commands. Perfect for getting your hands on experience with Unity's transform system. I have already set up a project. It's called Simple Sprite Manipulator. And of course you can name your project however you see fit. Just make sure that you start off with a 2D template. And the first thing of course that we need is a sprite. So let's go to Game Object, 2D Object, Sprites, and add a square sprite to our project. And unfortunately, as you can see, it's not centered in the screen, so I'm going to change its X and Y components. So now it's perfectly centered in the screen. Next up, we need a script. So let's go to the project panel and right click, create scripting, a mono behavior script, and let's call that Sprite Manipulator. So now it will compile for the very first time, so we just have to wait for a teensy bit, but it's virtually empty, so it goes really quick. Now let's add the script to the sprite. So we just go to the script, left click and drag it onto the sprite, and to verify or make sure that it's actually added, if we go to the sprite, we can see in its properties that the script has been added. So let's open up the script, and this is where Visual Studio will start, of course. And one of the first things that you will see is that there is some default code in place already. But instead of working around with the existing pieces of code, let's wipe it all clean. So I press Ctrl A, hit the delete key, and now everything is gone. And we can just start from scratch. And this way we can fully understand and control every part of our script. And we start off with a very simple line of code, but it's a very important one. We want to make sure that we're able to use all the functions, all the tools that the Unity engine can provide us. And to do that, we need to import the Unity engine library. And we can do that with the following statement: using Unity engine, and finish or end with a semicolon. And without this statement, Unity will not recognize game objects, transforms, inputs, debug logs, or whatsoever. So without that specific statement, you cannot do anything. So it's important. Next up, we need to identify to Unity what we are. And the way we do that is by saying we are a public class, and then the name of the script, which was Sprite Manipulator, and make sure it matches exactly the script's name, otherwise you will get errors. So this statement, public class Sprite Manipulator, is saying or telling Unity, hey, hello, we're here and we're called Sprite Manipulator. Now we also want to make sure that we can attach the script to any game object, and in order for us to do so, we need to inherit from mono behavior. And the way you do that is by writing or typing down a column. Use the keyword mono behavior. Like this. Yes. Then we need to add some curly braces, And every bit of code that needs to happen or that needs to be carried out will be in between these brackets, and those brackets are used to group lines of code together, creating a code block, and they define where a function, a loop, or a conditional statement starts and ends. So in this case it starts here and it ends there. Next up, let me insert some space there. Next up, we need, of course, to check continuously to see whether or not the player is providing input. So every time a player presses a key, we either need to move the sprite, or rotate the sprite, or scale the sprite. And to do just that, there's a function called update. And that function will run every single frame, which means it is executed many times per second. So for example, if your computer is able to process 100 FPS, 100 frames per second, it means the code within the update function is executed or carried out 100 times every single second. So we need to call that important function, and we do that by typing in update, and it automatically adds the update function. Now we can remove the private keyword that's not important in our game, and what you will see now is that it has created a void update function together with some curly braces again. The void bit signifies that it's empty, which is good enough for us because we don't expect the function itself to return any values that we use somewhere else within the script or within the scene. So now we need to start thinking about what do we want to happen every single frame. And I want to break that down and use some pseudocode for that, just to understand what needs to happen at what moment. So let me just write it down, and I use 2 slashes, and what you can see is that C# has turned those slashes green, meaning that it will be considered a comment, and it will not be compiled or executed. So you can think of this as notes to yourself as a programmer. And now we need to think a bit, what do we want to happen every single frame? Well, if the user presses the M key, I want the sprite to move to the right. And I would like, just as a precaution, kind of, I want a small message in the console window saying sprite moved. So if the user presses the M key, I want the sprite to move to the right, and a small message in the console window telling me the sprite is moved. Now I can just copy this bit and paste it in. If the user presses the R key, I want the sprite to rotate, and a small message in the console window that the sprite rotated. And I'm going to indent this slightly by pressing the tab key. And oh, let's indent again. If the user presses the S key, I want the sprite to be scaled. I want the sprite to scale. And I want a small message in the console window saying that the sprite scaled. If the user presses the M key, or if the user presses the R key, or if the user presses the S key. This ensures that within one frame it will be checked whether the M, the R or the S key has been pressed. Okay, so this is just some mental notes now that provides a sequence of events that we can convert into coding. So let's start with the first one. If the user presses the M key, and Unity has got a very neat trick to identify user inputs with the keyboard. So let's make use of that. If the input dot gets key down, key code is M, then I want you to do something. So if there is any input where a key is being pressed, get key down, and that key happens to be the M, then I want you to do something. That's basically what that statement is saying. Now I want to move to the right, and we need to think a bit and ask ourselves, what is movement? Moving an object, of course, is I have an object which goes from its current location to another one. And the current position of any object is given to you via the transform component within that object. So if we briefly go back to Unity and take a look at our sprite, this is the transform component, which details information about the position, the rotation and the scale, and it shows you the exact coordinates, the current coordinates of that sprite. Now, the important thing, and maybe you've seen it already, is that despite the fact that we created a 2D game, Unity still uses 3 axes, the X, the Y and the Z, to define its position, its rotation and or its scale. And that's just the way Unity works, really. So now let's go back to the script. Okay. We know that the transform component details information about the position, the rotation and the scale of the object. And we can access that information by typing transform.position. This statement basically is the current or position of the object. And if I want to move the object, I need to add something to its current position. And within Unity, that's done by a so-called vector tree. And a vector in Unity is a data type. It stores an X, a Y and a Z value, and it represents a position or a direction in space. Now, you might wonder, why would we use a vector tree in a 2D game? Well, like I pointed out already, even in a 2D game, Unity uses 3 axes within the transform component. That's just the way it works best. So what we can type now is the position of the object would be its current position, transform.position, plus a new factor 3, and it's new because we haven't identified it yet, and we want to move to the right a bit. We don't want to go up nor make use of the z-axis. Doesn't make sense, or would not make sense. This simple statement should ensure that we move one space or one step to the right. If we would use -1, it would go to the left. So we will go and test it out, but not before I add a small debug log. Debug.log. I want to show a message in the console window saying sprite moved, and finish with a semicolon again. This code should work, so let's save it. Let's go back to Unity, wait until it has compiled, and when it's done, let's press the game key, the play button. If I press the M, yes, it will move around. Okay, and let's see, there's a very small message in the left corner, bottom left corner, saying the sprite moved. And if I go to the console window, I can indeed see that it moved 6 times. And that's exactly the number of times I pressed the M key. So let's stop playing and let's go back to the script. Now we need, of course, to do the rotation bit. And we can just copy the first part of the movement code. So if there is any input, when a key is being pressed and that key is an R, I want you to do something, and I will put that in between some curly braces again. And what I want to do is, of course, I want to rotate this time. And rotating the sprite looks a bit like moving, but instead of using transform.position, we use transform.rotation. Oh, no, rotate, excuse me. And we just fill out some x, y, and z values. We don't have to add a factor. We just say we want to turn a certain amount on the z-axis. Rotating over x or y will not show any difference. So that's why we use the z in this specific case. We want to add a small message again in the console windows saying the sprite rotated. And for the scaling bit, we can use another input saying if there is any input, there's a key being pressed and the key is the S key, then I want you to do some code which is in between the curly braces. Let me just fix up these comments a bit. And to scale the sprite, you might think that you use transform.scale, but scale as such does not exist within Unity. Unity refers to local scale. So It's just one of those things. We have to use the local scale, and we say its local scale would equal transform.localScale plus a new factor 3 something like this, 1F00. And again, I want a message saying that the sprite was scaled. Nice, it's looking good. So let's save this. Go back to Unity and let's see if it works. Oh, yes, there's Unity. If we press the play button, it's going to compile the script. If I press the M, the S, or the R, S, M, and we can see that the sprite is moving, rotating, and scaling. And if we take a look at the console window, you can see that indeed the little messages are written down here. Apparently I pressed the R key 4 times, the S key 4 times, and the movement key or the M key 9 times. Okay, it's looking good, but we're not there yet because I'm not too happy with the way the code looks at the moment. There's two problems really with it. First of all, Unity has got an easier way to write down that I want to add something to itself. So instead of writing down transform.position equals transform.position plus the new factor, what I could write down is transform position plus equals the new factor. And this basically, or this means the same thing as the previous statement, transform.position, its position, equals, plus equals, its position, plus the factor. And we can do that trick here as well. The scale is going to be its current scale together with the new factor. So that's one thing I wanted to fix. And another one is that currently, of course, the values or the steps to move with or rotate with or scale with are hard coded into the script, and I don't want that. Whenever you have a large script or a huge script, it can be very tedious to find the actual value if you do want to change it. So to help us out, we can define some so-called variables, and those are like storage boxes in programming. They hold data like numbers or text or objects that can change while your program runs. And there's several kinds of them. There's integers for whole numbers, or floats for decimal numbers, strings for text, booleans for true or false statements, and several more. So let's create our first one, and let's call that one move amount. So we go and make a public variable called public float move amount, and we assign it a value of 1f. And what we can now do is copy this name, go here and just add it in here. We also make a public float rotation amount, equals 15 F, and we can just insert this one here, and we create a public float scaling amount, which would equal 1F again, and we can just insert that right here. So let's save it, and if we go back to Unity, yes, if you take a look at the sprite, what you will see now is that the variables have been added as properties within the script. And if we play, let's wait a bit until it compiles. If I press the M, it moves, it rotates, and it scales. But I can also change the move amount, let's say to 6. And if I now press the M, it moves way further. Or if I change the rotation amount to, let's say 120, and press the R key, it rotates much more than previously. And if I do scale way more, then you can see it scales 4 times more than previously. So it works. And let's check the console window. Yes, everything is still turning up. So that's good. And at this stage, really, some congratulations are in order, because your very first application is ready. You did it. Your sprite is now moving, rotating, growing, just like we planned. And now it's time to take control and experiment even further. Add keys to move up or down. Make the sprite rotate anti-clockwise or shrink instead of growing. And the best way to learn is really by tweaking and breaking your own code. So just experiment and see what else you can create. If you do have any questions, drop them in the comments. And in the next episode, we're diving into the Unity Asset Store, where you can find free and premium assets to bring your game world to life. Take care and bye-bye.